Asking the right question. So far we have been trying to solve the demarcation problem, which is a seemingly simple question. What makes science special? What is the difference between science and other things? We have already looked at and discarded 6 answers. The most recent answer was Kuhn's idea that what makes science special is its puzzle-solving characteristic. So, to recap, the answers we looked at are the common view, inductivism, verificationism, falsificationism, Kuhn's idea that science is special because it solves puzzles, and Lakatos's idea that science is special because it can make novel predictions. The common view and inductivism were almost embarrassingly bad. They proposed implausible methodologies that had no connection with reality. These 4, however, had some advantages. There are also some serious problems with them. Indeed, these problems are so serious that I'm inclined to think that none of them provide a satisfactory solution to the demarcation problem. It seems I'm in good company. American philosopher Larry Laudan also thinks that each and every solution to the problem ultimately fails. But let's not get ahead of ourselves. In his paper, The Dissolution of the Demarcation Problem, Larry Laudan does 3 things. First, he provides an expansive overview of the failed attempts to solve the problem. Indeed, he goes much farther back than we did. He starts with Plato and Aristotle. But I will spare you a discussion of that long history, since the views of the ancients are at least as bad and implausible as the common view of science we encounter today. Laudan then provides a diagnosis of what went wrong with all those ancient and modern solutions. To explain what went wrong, he first lays out what he calls the adequacy criteria for a solution to the demarcation problem to be successful. On page 118, he argues a demarcation criterion must identify the epistemic or methodological features which mark off scientific beliefs from unscientific ones. We want to know what, if anything, is special about the knowledge claims and the modes of inquiry of the sciences. He is absolutely right about this because we don't want the demarcation line to be trivial. For instance, suppose by sheer luck, all scientists have last names that start with the letter Z, and no one else has a last name that starts with Z. If you said a practice is scientific if it is the profession of someone whose last name starts with Z, you're correct. But you didn't solve the demarcation problem because you didn't explain why science is special. What's more, the need for an epistemic or methodological solution also explains why verificationism and falsificationism are hopeless. To see why, let's draw a distinction between semantics and epistemology. Semantics is the study of meanings of statements and their parts. Consider the statement, Sam came home after school. A semantic analysis of this statement asks the following questions. Who is Sam? Which school? When is school? Where is home? One cannot understand that statement without answering those questions correctly. On the other hand, we have epistemology, which is the study of justification and evidence. An epistemic analysis of the same statement takes its semantics for granted and instead raises very different questions. What evidence is there for and against believing that Sam came home after school? How reliable is that evidence? And ultimately, should we believe the statement based on that evidence? Now let's think. Is the statement Sam came home after school verifiable or falsifiable? The answer to that question depends almost entirely on semantics and has nothing to do with the epistemic merits of the statement. If Sam is a vampire who lives next door to you and his school ended this afternoon, you can go see if he did or did not come home after school. If Sam is a perfectly normal, unremarkable human child who lived in Rome sometime in the 3rd century BC, then the statement would be unverifiable and unfalsifiable because any records about Sam are probably long lost to history. Either way, however, the statement being verifiable or falsifiable doesn't make the belief that there is a vampire next door to you who came home after school any plausible. If that didn't make much sense, consider another example. Aliens who look just like Transformers will land on a planet tomorrow and start fighting in the most ferocious manner. Is the statement verifiable or falsifiable? Well, it depends on semantics. Indeed, the phrase a planet is ambiguous. It could be referring to a specific planet, like Earth, or it could be referring to any planet. If the referent of the phrase, a planet, is Earth, then the statement would be both verifiable and falsifiable. After all, these robots are very big and violent. It would be hard to miss them if they land on Earth and start fighting in the most ferocious manner. If, on the other hand, a planet is referring to any planet, then the statement is unverifiable and unfalsifiable. If they landed on a planet in a faraway system or galaxy, we would have no idea. Should we believe it, though? Should we believe that Transformers will land on a planet and start fighting? Again, if we are talking about Earth, the answer is no. If anyone in class wants to bet money, I got $100 that they won't land on our planet tomorrow and start fighting. But if we are talking about any planet, I hesitate. I hesitate because the universe is vast, perhaps infinite. I have no idea what exists out there. Perhaps there are aliens somewhere out there who look just like Transformers who are going to land on a planet tomorrow and start fighting in the most ferocious manner. As Laudan puts it on 121, verificationism and falsificationism focus on testability. Testability is a semantic rather than an epistemic notion, which entails nothing whatever about belief worthiness. Indeed, there are lots of testable but incredible claims, such as the claim that tomorrow the sun will fail to rise and will be replaced by Donald Trump's undergarments. There are also lots of credible but untestable claims, such as the claim that there are planets in faraway galaxies. Therefore, testability cannot explain why science is special, epistemically speaking. So verificationism and falsificationism are non-starters. But what about Kuhn and Lakatos? Laudan doesn't directly engage Kuhn and Lakatos, but we can easily connect the dots. On page 117, he argues that any proposed dividing line between science and non-science would have to be sensitive to existing patterns of usage. For instance, if your solution to the demarcation problem says physicists aren't scientists, but people who do chakras and auras are scientists, then your solution fails. As we observed earlier, Kuhn has a problem here. He can't explain why astrology isn't scientific. After all, astrology is also about solving puzzles. Lakatos also has a similar problem because he can't explain why inorganic chemistry or economics are scientific. They make few novel predictions, that's true, but common usage of the word science includes all branches of chemistry and economics. To understand what went wrong here, we should think about necessary and sufficient conditions. According to Laudan, a demarcation criterion should specify a set of individually necessary and jointly sufficient conditions for deciding whether an activity or set of statements is scientific or unscientific. Kuhn's failure is a failure to specify the necessary conditions for a practice being scientific. Therefore, his demarcation criteria are too permissive. Demarcation criteria are like bouncers. They are supposed to let in all and only scientific theories and practices. Suppose being scientific is like wearing a special bracelet that shows that you are invited to the party. Kuhn is like a bouncer who doesn't know that someone must have bracelets to answer. So in addition to the legitimate guests who were invited, he lets in questionable types like this gentleman here. Lakatos has the opposite problem. He fails to identify the sufficient conditions for being a science. He is like a bouncer who doesn't let people in although they have the bracelet. The result is, of course, a ton of angry customers or invited girlfriends. You might be wondering, can't we do better than Kuhn and Lakatos? Laudan thinks that we can, but this will take a shift in perspective. Laudan thinks that it is futile to try to contrive a set of necessary and sufficient epistemic conditions that apply to all and only science. This is because science, according to him, is not epistemically uniform. Science is epistemically heterogeneous. Laudan says science is not all cut from the same epistemic cloth. Some scientific theories are well tested, some are not. Some branches of science are presently showing high rates of growth, others are not. Some scientific theories have made a host of successful predictions of surprising phenomena. Some have made few, if any, such predictions. Some scientific hypotheses are ad hoc, others are not. Some have achieved a consilience of inductions, others have not. Let's call this the epistemic heterogeneity of the sciences. Different theories, and perhaps even branches of science, enjoy different quantity and quality of evidential support. For instance, the Big Bang theory is very well supported. We can clearly see that the universe is expanding, which indicates that it used to be compact. What is more, we can observe the cosmic background radiation fading after a glow of the incredibly hot temperatures that were possible only if the universe started from an infinitely compressed state. Contrast that to the multiverse theory. To put it diplomatically, there is no evidence for it, except maybe a few History Channel documentaries which host people with wild hair who ask questions like, was the Declaration of Independence written by aliens? So, two theories in physics in the same branch of science, but one of them is worthy of belief and the other one is pure speculation. You can perhaps say similar things about whole fields of science. On the whole, statistically speaking, physical theories tend to enjoy a higher quality of evidence than theories of psychology. We will understand why this is so when we discuss David Lycan's paper, What's Wrong with Psychology. And finally, some branches of science might even host claims that are even less plausible than simple common sense, as we will get to at the end of the semester. Here is the bottom line of all of this. Epistemically speaking, perhaps not all science is special. And again, epistemically speaking, perhaps not only science is special. If you remember, we started this course assuming that science is exceptional. We said science among all ways of knowing and dealing with the world is special. Science liberates us from oppressive institutions and forms of thought. Science does this by following a distinctive method that enables us to know the truth most reliably and effectively, and hence only science produces desirable results. And we laughed at Paul Feyerabend for rejecting the idea that science is special. We saw him as a mad philosopher with silly ideas. However, although there is much hyperbole in Feyerabend's ideas, I think there was also much truth. In particular, I think it is time we laid scientific exceptionalism to rest. I told a short story about Russell last time, if you remember. The journalist asks him, what is the meaning of life? Russell says, you are asking the wrong question. The journalist says, what is the right question then? And Russell says, you should ask, what is the meaning of life? Laudan is having a similar conversation with us. We have been asking what makes science special. Laudan thinks that this is an ill-conceived question because it presupposes that science is special. But scientific exceptionalism is false. Science isn't special, epistemically speaking. At least it isn't on the whole. So, What question should we ask then? Should we pick up our marbles and go home? Is philosophy of science finished? Or is there a path forward from here? Laudan, who has been critical so far, has a constructive idea. He thinks we should ask a new question. Which parts of science are worthy of belief and which parts aren't? And how can we tell the difference? Here's what that means. Laudan says, forget the demarcation problem. Stop trying to find the magic line that makes science special and superior to everything else. Instead, try to draw a line inside science itself. Which parts of science are worthy of belief and which parts aren't? And how can we tell the difference? So, we must try to draw a line, according to Laudan, between good science, which harbor claims that are worthy of belief, and junk science, on which we shouldn't base our personal and collective decisions. That is the path forward. But before I flesh out that path a bit more, I owe you an explanation, if not an apology. After all, at this point you might be thinking, if the demarcation problem was an ill-conceived question all along, why would we waste so much time looking for answers to it? Why did we bust our brains thinking through this list of solutions which had no chance of accomplishing anything meaningful? Think about it this way. If I told you only that Thanos dies at the end, or Raskolnikov confesses and goes to exile in Siberia with Sofia, you wouldn't understand the Avengers movies or Dostoevsky's novel Crime and Punishment. Similarly, we had to go through these solutions to comprehend the gravity of their failures. Just like the scientific method, the free lunch is fictional. Understanding the failure of the attempted solutions was necessary to understand the need for an alternate path and what that path might look like. And finally, now you understand the path forward. We will try to understand the difference between good science and junk science. To do that, we will look at specific examples closely. We will see scientists cheating and getting caught. Scientists who were perhaps falsely accused of cheating. Scientists suffering from mass hysteria and collective delusions. Scientists trying hard and still failing to explain and predict phenomena. And finally, scientists cheating and perhaps getting away with it. This brings me to the end of this lecture. Send me an email if you have any questions. I thank you for your patience, and I'll catch you next time.